So again, the properties that we went over for logarithms, and again, this is one of the reasons logarithms tend to be a little bit difficult to figure out, but once you get them, they have some really awesome properties. Okay, so they allow us to change into much simpler operations. So generally speaking, multiplication is harder than addition. So if we can change a multiplication problem into an addition problem, we're in pretty good shape. So if this is log base a of m times n, we get log base a of m plus log base a of n. And remember we said this is it's called an identity. It's a true equation. It works this way and it works the other way. It works from left to right and right to left. So depending on which way is more convenient for you, you can use the property in both directions. Quotient changes division into subtraction. The one on the top is positive, the one on the bottom is negative. Okay, so we put a negative out front of that log base a of n. Okay, we've got this power property, which is really cool. I can take the exponent, move it out front, or I could take the factor out front and slide it up there and make it an exponent. And then we've got this change of base formula, which allows us to take any logarithm, no matter what the base is, and make it something that we can compute on our calculator. So that little formula is extremely useful, one we definitely ought to know. And then we also talked about the fact that the cool thing about logarithms is if you've got an answer, usually you can plug it in and check and make sure that it actually works, okay? Because a logarithm is the exponent on the base. So if I find log base 3 of 4 and I think it's 1.26, I can check by taking 3 and putting a power of 1.26 on it. And if it's 4, then we know that's the right answer, okay? So I pointed out that on a lot of these problems, what we're going to be doing is we're just going to be manipulating these a little bit. We're going to be using these properties to rewrite an expression. So we're not really going to get a number answer. Okay? We're going to get a new funny-looking expression in most of these problems. So let's go back and let's take a look at the second part of example 8. It says, given that ln of 2 is represented with the letter A and ln of 3 is represented with the letter B, so whatever this number is, we're going to use an A in its place. And whatever this number is, we're going to use a B in its place. Figure out how we can write the ln of 6. Well, the first thing I need to have is I need to have a 2 and a 3 here. So I'm going to rewrite this as the ln of 2 times 3. So it's a multiplication problem now. And once I've got it written as a multiplication problem, logarithms allow me to change multiplication into what? Addition. So I'm going to do the ln of 2 plus the ln of 3. I break this single logarithm into two separate logarithms. Okay, and if they said I could be done there, I could be done right there. But what are we using in place of ln of 2? A. And what are we using in place of ln of 3? B. That's the answer. Looks weird, seems like, my gosh, why would you want to do that? Again, it's just practice manipulating these things, just using those properties to rearrange them. Okay, any questions there? Okay, the instructions for example 9 were this. Write each expression as a sum or a difference, plus or minus, okay, of logs, and write powers as factors. So remember, anything in the numerator is going to have a what in front of it? Plus or a minus? A plus. Anything in the denominator is going to have a minus in front of it. So we're going to rewrite this way. So let me make that a little bit bigger. We're going to write this as a bunch of different logarithms. So I'm going to write the log of u to the 5th minus the log of v to the 2nd minus the log of w to the 6th. Okay? Anything I'm dividing by has a negative in front of it. Anything that's up in the numerator just has a positive in front of it. Okay, are we done with this problem? We are not done with this problem. Okay, so I want to take each one of these and I want to slide those out front. So this is going to give me 5 log of u minus 2 log of v minus 6 log of w. And this, as ugly as it is the answer. That's a much more condensed format. But these two expressions are the same thing. This is where I started, and I used the properties of logs to write it as a bunch of separate logarithms with factors out front. Any questions there? Okay, watch please. You don't need to write this. Would it be okay if I wrote this? Is that the same thing? Can I take this exponential, move it into the numerator, and change the sign of the exponent? Change it from positive to negative, negative to positive. Is that okay? Okay. So if I did that, then this is now a multiplication problem, right? So this would be the log of u to the fifth plus the log of v to the negative 2 plus the log of w to the negative 6. Okay, using the product property of logarithms, I change multiplication into addition. And then if I slide these exponents out front, 5 log of u, whoops, bring that 2 out front, that negative 2 out front, that would be negative 2 log of v, and this would be minus 6 log of w. Okay? Same thing I got here, just a different way to do the same thing. Do you see why, if it's in the denominator, it has a negative out front? Because when it's in the denominator, that really means a negative exponent. So when we slide it out front, it would be negative. Any questions there? Sure? Okay. What's the base of this logarithm? 10. Thank you very much. Very good. Okay, let's take a look at this one right here. I'm going to give you a little bit of a head start. We want to write this as a sum or difference of logs. So I want to rewrite this one right here as a sum or difference of logs. We want to write it as a couple different logarithms. Anything in the numerator is going to have a positive in front of it. Anything in the denominator is going to have a negative in front of it. Go ahead, write down what you think the answer ought to be. And I don't mind you skipping steps as long as you get it right. If you're going to skip a step, make darn sure you got the right answer, okay? So I'm not going to skip a step. I'm going to write log base 4 of x squared, and then I'm going to write minus log base 4 of 5x minus 6. Okay, now remember I said radicals don't play well with logarithms? So instead of writing this as a cube root with a radical sign, what am I going to write? Fractional exponent, rational exponent. That's going to be to the 1/3. Everybody good there? Okay, I've got to have those two pieces, and then all I need to do is slide the 2 out in front and the 1/3 out in front. So this is 2 log base 4 of x minus 1/3 log base 4 of 5x minus 6, and that would be the answer. As ugly as it is, that's the answer. Again, all we're doing here is just manipulating these. Okay, any questions? Okay, so the instructions for this part of the assignment were different. On number 10 it says condense the logarithm. In other words, write it as a single logarithm. Here we took a single logarithm and we broke it up into a bunch of different parts. Here we're going to take a bunch of logarithms and we're going to condense it and write it as one single logarithm. Okay? So we're going to take this one and we're going to rewrite it. So this is going to be log base 6, one single logarithm. I'm going to slide this up here. Where's it going to go? On the top or the bottom? It's going to go on the top. Why is it going to go on the top? Because it's positive. Okay? So this is going to be x to the 4th. Okay? I'm going to slide this up here. That's going to be y to the 3rd. Raymond, where's it going to go? Top or bottom? Y bottom. If it goes on the bottom, it would need to have a negative in front of it. So this is going to be y to the 1/3 on the top, because this is positive right here. See how these guys are positive? Okay? If it's got a negative in front of it, when I slide this up here, that's going to be minus log base 6 of z to the 5th, and because of that minus, it's going to be in the denominator. So that's going to be z to the 5th down here. That's the answer. Now, if you wanted, we could write it like this. So they're all plus. I'll write it as a single logarithm with all of them being multiplied together. So that's to the 4th That's to the 1/3, and that's to the negative fifth. But again, we normally don't write it with negative exponents, so I'd slide that in the bottom, and it would look like this. Any questions? Sure? Okay. All right, let's take a look at this one right here. This one's kind of interesting. You do have a couple problems like this on your assignment. So we need to take this, and notice that we've got a 3 here. Any ideas on this one? 3 out front in these square brackets. Okay. What we really need to do here to understand what's going on is we really need to distribute. So I'm going to write this as 3 log of 1 over x plus 3 log of x minus 6. I'll put that in parentheses. Okay. Now, I'm not going to bother rewriting this. I'm just going to go ahead and write minus log of x minus 6 raised to the 5th. Is that okay? They're all the same logarithm, so I'm going to write one single logarithm. They're all log base 10. Okay, this is going to be 1 over x raised to the 3rd. This is going to be x minus 6 raised to the 3rd. This is x minus 6 raised to the 5th. Where do I put it, Noah? I put it in the bottom because it's got a negative out front, right? So this is x minus 6 raised to the 5th. Now, let's look at this for just a second. This certainly isn't as simple as we could write this. Is there anything I could do with this? Could I clean this up just a little bit? Can I cancel anything? I can cancel 3 of these with 3 of these, right? So there's 2 left. So then I've got this. This is the log of, I'm going to write 1 over x to the 3rd over x minus 6 raised to the 2nd. Is that okay? Everybody okay with that? Okay, now I'm going to remind you of something that we've practiced in this class. That I gave a calculus test yesterday, and I had students miss some complex fractions. They missed an algebra part of a calculus test, so they got a calculus answer wrong because they didn't know how to deal with complex fractions. Okay? This is this fraction divided by this. So if I put that over 1, do I ever divide by a fraction? I flip it over and I multiply, right? So I'm going to cross this off, and I'm going to write it as 1 over x minus 6 quantity squared. That's where it goes. I had students that put that in the numerator rather than in the denominator. Okay? So that means the correct answer to this one is the log of, I'm going to have a 1 on the top, and I have an x cubed and x minus 6 squared. That's not the only way to arrive at that answer, but that's the correct way to write this as one single logarithm. Okay? Any questions? Okay. So that's a bunch of practice on the techniques that you're going to use in this section. I want you to take a look at the last little bit here. Down at the bottom, it's got a true-false question, and then it's got a couple problems where it says, just go ahead and figure out what the answer is on this. Okay? So this one says true or false. Log base b of x plus y is log base b of x plus log base b of y. In other words, what they did basically is they distributed that to each one of those. Okay, does that work? Okay, at this point, do you think it works or not? Raise your hand if you think that works. Okay, a couple of you brave enough to say, yeah, I think that works. Raise your hand if you say, no, I don't think that works. Okay, a couple more say no, and some of you are not voting. That's not quite fair, but it is 8:30 in the morning. Okay, so the answer to this is that's false. This does not work. Okay, that is not true. Okay, very few functions distribute. Very seldom can you distribute a function through to some of its terms that it's applying to. Okay, now the way you could check this is you could plug in some numbers. Let's say we did log base 10 of 10 plus 10. So this would be log base 10 of 10 plus log base 10 of 10. So the question here is log base 10 of 20 the same as log base 10 of 10 plus log base 10 of 10? If you're not quite sure, plug in some numbers and see if it works. Don't be satisfied with just one number. If it works with one number, it doesn't mean it works for all numbers. But if we find one number that it doesn't work for, there's no way this is true. Okay? 10 to what power equals 20? We can plug that into our calculator and find what it is. It's a little bit more than 1. What's this number right here? 1. What's this number right here? 1. Add up to 2. This side is 2, and there's no way this is a 2 over here, so it does not work. Okay? You could numerically check and see whether or not it works. Okay? Let's take a look at this next one. This is log base 3 of 12 minus log base 3 of 4. Do you know what either of those numbers are without using a calculator? Nope, but watch. Something we don't know minus another thing that we don't know. Use the property of logs. This would be log base 3 of 12 over 4, which is the log base 3 of 3, which is a problem we do know because that answer is 1. What exponent do we put on a 3 to make a 3? We put a 1 on there. Okay? Now, let's take a look at this one right here. This is log base 16 of 64. Log base 16 of 64. Okay? Anybody know what the answer is? Good, because I don't. I haven't done this problem before. I don't know if I've done a million math problems in my life, but it's probably getting pretty close. I've not done this problem before. Okay? We are looking for an exponent, right? We're looking for the answer to a logarithm. If you don't know what the answer to a logarithm is, we could rewrite it as an exponential, right? So this is saying 16 to what power equals 64? 16 to the first? Nope, because that would be 16. 16 to the second? Nope, because that would be 16 times 16 is 256. That's way too big. Okay? So it's got to be somewhere in between 1 and 2. Okay? So here's a little primer on what we're going to be doing in section 3.4. Okay? This is what we'd call an exponential equation. We're trying to find an answer to this. Okay, now, do 16 and 64 have anything in common as far as exponentials go? They are both powers of 4, aren't they? Isn't this 4 squared? And isn't this 4 cubed? Okay, if I have a power raised to a power, what do I do with the exponents? Multiply them. So this would be 4 to the 2x equals 4 to the third. Now just take a good look at that. If I said 4 to the 2x equals 4 to the third, by logic, couldn't we figure out that, well, wait a minute. If the bases are the same, shouldn't the exponents be the same? Shouldn't 2x equal 3? So shouldn't x equal 3/2 or 1.5? Didn't we say the answer was going to be between 1 and 2? Gosh, here it's smack dab in the middle. Okay, now, how could we check to see if this is right? It's an exponent, right? It's an exponent on 16. So on your calculator, type in 16 to the 3/2 or to the 1.5 and see what you get. You get 64, don't you? Okay, so that's the correct answer there.